Hi everyone, this is Aman Sophia, Assistant Professor in Triple Department. In today's lecture, we are learning about EMI subject, that is Electrical and Electronic Measuring Instruments. Before going to start our subject, we must note the different types of electrical instruments as well as electronic instruments. Electrical instruments are used for measuring electrical quantities like current, voltage, power, and so on. See, examples for electrical instruments are ammeter, voltmeter, and wattmeter. These instruments can be used to measure. Ammeter is used to measure the value of current, and voltmeter can be used to measure the value of voltage. Okay, and wattmeter is used to measure the value of power. Whereas electronic instruments are which measures some electric, magnetic, and electromagnetic quantities. Those are called as electronic instruments. Okay. Coming to what is mean by measuring instruments means instruments which compares unknown quantity with a standard quantity is called as measuring instruments. Or you can also say that it's a comparison between known value and the unknown value is known as measuring instrument. The comparison between known and unknown value. In today's lecture, we are seeing the basics of measuring instruments. Let us see some important electrical quantities to be measured. Like first of all, we are considering an electrical quantity like current, which can be known as the flow of electrons is known as current. Its units are amperes and it can be denoted with the letter capital I, and the instrument used to measure the value of current is ammeter. Next one is voltage. The potential difference between 2 points is known as voltage. It is denoted with V and its units are volts. And the instrument used for measuring voltage is voltmeter. Resistance, which opposes the flow of current, is known as resistance and is measured with the instruments ohmmeter or megger, and its units are ohms. Inductance. So inductance is denoted with L. Inductors are the instruments which stores the energy in the form of magnetic form, that is known as inductor, and its units are henries, and the meter used is LOR meter. The next one is capacitance. Capacitance is denoted with capital C, which stores the energy in the form of electric, is known as capacitance, and its units are farads. And the meters which can be used to measure the capacitance is capacitance meter or LOR meter. Power. Power's units are watts, and the instruments used is watt meter. Energy. Coming to energy, its units are watt hour, or we can say that kilowatt hour, and the instrument used is energy meter. Frequency. Frequency denoted with F. Number of cycles per time is known as frequency. If you want to write the formula for frequency, you can write it as F equals to 1 by T, and its units are hertz. The instrument used is frequency meter. So the different types of electrical quantities to be measured. And next we are seeing the different types of measuring instruments to measure the different types of electrical quantities. Like first one is of ammeter, which can be used to measure current, voltmeter to measure the value of voltage, wattmeter to measure power, watt hour meter, or you can say this energy meter to measure the energy. Next, ohm meter to measure the value of resistance. Multimeter can be used to measure current, voltage, resistance in both AC as well as DC. power factor meter, frequency meter, electrometer. These are the different types of meters are used to measure the different types of electrical quantities. Coming to the classification of measuring instruments can be classified into different types based on its nature of output and principle of operation. First of all, we are seeing the classification of instruments based on the nature of output. So, coming based on the nature of output, the instruments are classified into two types: analog instruments and digital instruments. So you can see the difference over here. Analog instruments means which uses a scale and pointer. Coming to digital instruments will give the output in the form of digits. See, the analog instruments are which gives the output in the continuous function, in the form of a continuous function of time, is known as analog instruments. Otherwise we can say that the instruments which gives the output by using pointer and scale are known as analog instruments. But measuring the output value by using analog instruments, some human error will be occurred over here, and this will not give accurate value. And examples of analog instruments are deflection type ammeter and deflection type voltmeter. The next classification is digital instruments. Digital instruments are those which gives the output in a finite number of values, are known as digital instruments. So by using these instruments, no human error will occur, and it will give the accurate value than that of analog instruments. So this is the based on the nature of output. Instruments are two types, analog as well as digital instruments. Compared to analog instruments, digital instruments will give more accurate value. The next classification is based on the working principle. When the instruments are used, some amount of effects are exist over there, like a magnetic effect, electrodynamic effect, electromagnetic induction effect, chemical effect, thermal effect. These are the different types of effects which are existing when an instrument is used. Let us see some different types of effects and what are different types of instruments, and these instruments can be used for which type of supply. Like we are having both AC and DC supply, right? All the instruments can't be used for both AC and DC. So based on its effects as well as working principle, some instruments are used for AC and some instruments are used for DC. The first effects we considering is magnetic effect. So magnetic effect exists in moving iron type instruments, and these are suitable for both AC as well as DC. And the instruments used are like ammeter and voltmeter. The next effect is electrodynamic effect. This type of effect exists in PMMC instrument. PMMC nothing but permanent magnet moving coil type instruments. These instruments are used for only DC, and the instrument used are ammeter. The next effect is thermal effect. Thermal effect exists in hot wire type instruments, and hot wire type instruments can be used for both DC as well as AC, and the instrument used are ammeter and voltmeter. The next effect is chemical effect. Exists in electrolytic meter type instruments which are used for DC, and the instrument used is ampere hour meter. The next one is electromagnetic induction type effect. It is existing in induction type instruments which is suitable for AC, and the instruments used are in ammeter, voltmeter, wattmeter and energy meter. This is the classification based on the working principle of instruments. Coming to the main classification of measuring instruments. Measuring instruments are mainly classified into two types: absolute instruments and secondary instruments. This is the main classification of measuring instruments. See, absolute instruments nothing but which gives a constant value. Those are known as absolute instruments. Yet here, uh, in absolute instrument, measured quantities will not compared with the standard quantity. That is known as absolute instruments. Absolute instruments are those which gives the quantity to be measured in term of instrument constant, and its deflection requires no comparison with any other standard instruments, are known as analog instruments. Examples for analog instruments are tangent galvanometer. If you want to say in a simple word, means the instrument which gives the direct value. That means it here will not compare the measured value with any other value. Those are instruments are known as analog instruments. Whereas secondary instruments, in secondary instruments, measured value is measured value is compared with the standard value. Those instruments are known as secondary instruments. The instruments which gives directly the value of quantity to be measured by amount of deflection which is recalculated with the absolute instrument is known as secondary instruments. These instruments are classified into three types: indicating instruments, integrating instruments, and recording instruments. Indicating instruments are those instruments which make use of a dial and pointer for indicating the magnitude of unknown quantity is known as indicating instruments. The instruments which uses a dial and pointer, nothing but a scale and pointer, to indicate the quantity is known as indicating instruments. Examples for it: voltmeter and ammeter. Next one is of recording instruments. Recording instruments gives continuous record of the given electrical quantity over a specified period is known as recording instruments. Nothing but which gives a continuous record is known as recording instruments. The next classification is integrating instruments. So integrating instruments are the instruments which measures the total quantity of electricity delivered over a period of time. Total quantity of electricity delivered over a period of time are known as integrating instruments. Examples for integrating instrument is household energy meter or domestic energy meter is the example for integrating instruments. See, in absolute instruments, we are not comparing the measured value with any other values, whereas in secondary instruments, we are comparing the measured value with the standard value. That's the difference between analog and secondary instruments. See, absolute. Coming to secondary instruments, they are classified into three types: indicating, recording, as well as integrating instruments. Indicating instrument examples are ammeter and voltmeter. Integrating instruments examples: household energy meter. Let us see the difference between absolute and secondary instrument. As just now I said, see, in absolute instruments the quantity measured is constant, whereas in secondary instrument it gives the value of quantity to be measured in terms of deflection only. Whereas in absolute instruments it does not require any previous calibration, whereas in secondary instruments it requires previous calculations such that it can be compared with the standard value. The measured value can be compared with the standard value, whereas absolute instruments can be used in standard laboratories. Secondary instruments can be used in all laboratories. Example for absolute instruments are tangent galvanometer, and absolute electrometer are the example for absolute instruments. Whereas coming to secondary instruments, examples are ammeter, voltmeter, wattmeter, ampere hour meter, watt hour meter. These are the examples of secondary